let's start. I just opened Grasshopper, and I usually start with new model. I open Grasshopper. There are some like helping. It opens with a screen with some helpful information. I usually start from new document just to have a clear board. But before I start, I will show you our first board and how we create it. When we start with Grasshopper, I want you to see it as a parametrical, like kind of compensation to one weakness in Rhino. In comparison with other modeling 3D modelers, Rhino has quite has a significant weakness. For example, if you work in 3D Max, the concept in 3D Max that you take a geometrical object like a sphere, a box, and then you apply modifiers to it, and you can apply a sequence of modifiers. And your final, like how this object looks like in the model, is the final view of this first object with all applied stack of modifiers. And at any point, you can modify any of these modifiers, adjusting how this object is presented in your model. In Rhino, you almost never have such thing. So in a way, Rhino is not driven by parameters. And it's a significant weakness for a modeling tool because it significantly limits your editing capacities. And in a way, Grasshopper can be viewed as a tool to compensate for that. And our first example just demonstrates exactly that. So how we can make basic, starting from basic Rhino objects, how we can make them parametric. So I want to play, say, with a sphere. So in Grasshopper, I will go to surfaces, and under primitive surfaces, I see main basic 3D objects presented in Rhino, and I see several instances of spheres. And as it is usual for 3D modelers, so the difference is how you specify location of the sphere. So we will use the simplest one. Okay, and this is, and you see, I put this object on the board, and immediately in Rhino, I have a preview what will be created by this element of my Grasshopper design. And it will be a sphere. How this sphere, what parameters define the sphere? So I can explore it from here. If I hover over this, on the left side, it's called inputs. So if I hover over B, I see that it's base plane, and R is the radius. Okay, so potentially I can change these parameters. Obviously, they're preset because we already see the sphere. So, but we want to modify them. How we can modify them? We probably can set a number manually, but of course, it's not what we want. We want some better parameterization. So in the params tab, let's see what we have. We have input elements. So, and input elements obviously allow us to put some, to create some some values, to put some values which we will be able to modify. Let's drag this one. It's a slider. And for a slider, you can just choose, change the value, like when I'm dragging right and left. So I'm changing the value of the slider. And now it is the output. Outputs are on the right side. and I will connect it to the radius. What will happen? Our sphere became smaller because now it's not the predefined value like radius. This element is taking the value from our slider as the radius of the sphere. So now I can, on the fly, I can modify the radius of the sphere. Okay, so now what about our base point? So for our purposes, let's take that it's just a point in space. So let's see what we can do here. What we can do here. So the simplest thing, we can just specify the point. So this is an element which allows us to specify the point, but this element just specifies a collection of predefined dots. So what we can do with this element, we can right-click it and say set one point. And then Rhino will allow us, for example, to specify the point by coordinates. 3, 4, 5. Yeah. And then our actual location, yeah. And then this point is set to 3 to 5. We can see it here, right? And then we can feed it into the input. And then the location of the sphere has changed, right? It's easy, but the problem with that actually, so basically I typed the location and we want it to be much more dynamic, right? So that's why my preference would be to be able to change coordinates of this point. But this particular element doesn't have these inputs, right? So we need to find another element which will allow us to change locations. Let's see what we have here. It's always a question where to find a particular element you need in, well, for this element. So it's described that this element constructs a point. So this element, obviously it takes 3 coordinates, x, y, z, and it will create a point. Okay, that's good. That's all we need. So we can easily create x, y, z as sliders. So we're dragging them here. And then we're connecting them. It will be our, it will be our z, it will be our y, it will be our x, yeah. And then we're connecting it to the b. Okay, so now when we are changing our sliders, okay, it's, yeah, just a moment.
Excuse me.
Yes.
For that last command with the XYZ, which button was that?
Sorry, for the last command XYZ, could you repeat your question?
Where was the button?
Oh, the button. So XYZ, so I found it in the vectors. And vectors, you have here construct point. You see here you have point, tab. No, point, not tab, point panel, right? And then I just found this construct point element. Okay? Yeah.
Thank you.
Yeah, you're welcome. So now, yeah, and now if I'm changing, it should change. Just a moment. Yeah, yeah. So, and now I can change the location. Probably it's better to look at it here. Yeah, I can change the location here. But what I don't like that I can change the location in such a small range. So I want to redefine the range in which I can change my location. So for a particular slider, I can right-click the slider and click Edit. And then here for a slider, I can specify minimum. And I want it to be from -10. And I won't specify the maximum. I want it to be +10. So now I can see that my range is 20. My current number is not important. I will be able to modify that. So, and now I can move my sphere significantly, the significantly wider range. I can modify my other sliders too and make my, and then I can change location of my sphere using sliders. So now I have a parameterized element and I can modify its radius, I can modify its location in different ways. Do you have any questions at this point? No.
How did you split the three coordinates into like different sliders?
Sorry, could you?
Like when you got the 3-point element thing, how did you split it into the 3 sliders?
Oh, okay. So this is, so I took this element and this element is called construct a point, right? So to construct a point in 3D space, you need three coordinates, right? X, Y, and Z, right? That's why this element has X, Y, and Z, 3 inputs, right? So now I need to create this input. What this input is obviously a numeric value, right? So I go to the params and on the input panel, I have number slider. It's an element. So I drag this element here and then I just feed it into the, it becomes my X. If I connect it, it becomes my X coordinate.
Okay.
Does it answer your question?
Yes.
Okay. Yeah. Okay, any other questions? Okay, then I will ask you to do this. I will ask you to open your Rhino, to open a Grasshopper, to choose, to take any Rhino primitive from panel surface primitives, like whatever you like. Choose a box, a cylinder, a cone, whatever, and try to parameterize it as I did. Like on your computer, if you using similar elements, just make it parametric and see how it works. If you have difficulties, just tell us. We will check what problems you have, and we will see how we can resolve that. Okay, so and just when you're done, just tell that you're done.
Can you do the same thing with the surface?
With this surface, I think yes. Why not? You have, for example, you take this 4-point surface, and then just specify 3 points or 4 points, right? So yeah, so whatever parameters you need.
Leo,
Yes.
if
Hi.
you like accidentally connect two things that you don't want to connect, how do you unconnect them?
Okay, so if to unconnect them, you have like, you can click, you keep control, and then you're following the same path, and it will delete the connection. Okay. Mm-hmm. Mhm. Okay, a few people haven't finished yet. So would you like to ask some questions? Because I'd like to go to continue. Okay, we will continue, so you will be able to, okay, good. So I hope you will be able to catch up. So what I don't like about my current kind of board, I don't like the fact that actually everything is manually is controlled by parameters in Grasshopper. I would like my point to come from some place in my Rhino model, not from a point specified on the board. It's a bit ridiculous. So what I will do, I want to use a curve. For example, I create a curve here in my top view. I'm creating a curve. Done. So, and I want to use the middle of this curve as the location point for my sphere. So how I can do it? So I will, let's say I will disconnect this point, pressing Control. So I can put this part of my board aside. So I won't be using it for now. And I want to feed somehow, to feed the middle of the curve into my sphere element and see how it will work. So I'm going to my curve, to the curve tab. And you see here in analysis, I have curve middle as an element. No, I will do it differently, sorry. I will do it this way. So we will, can I do it this way? Just let me think. Well, no, I will try to do it this way. Okay, it promises to give us the middle. Okay, let's see. So, and for the middle, you see this element, it takes a curve and it returns a midpoint. Okay, let's see how we can specify the curve. We can set one curve. Let's see if it allows us to choose one. Yes, it allows us to choose one. So, and now we can even see that it is the middle, right? So it's shown in Rhino. So, and now we will connect it to our base point. You see immediately our sphere moved, and now it's on our curve, and we can change the radius. But the beauty of it that if I'm changing the curve, so I'm taking my curve and I have some element, right? And I'm changing my curve. And when I'm changing it, my sphere will adjust. It will still on the curve. So, and I can control the location of my element with my geometrical element in Rhino. Basically, when I'm changing my model, this element will be also relocated. So I can, if I want, I can even connect, for example, as a part of my design, I want the sphere to be just half of the radius of the sphere, to be half of the curve length, right? So I can disconnect this slider and I can put, what other analysis we have here? Yeah, we have length. So we have length and we can, now you see I want to use the same curve and it's not exactly what, and then I don't want to use it like to select. I can select it second time. I can say set one curve, and I selected it again, and then I want half of the radius. I don't want to use like to be like the whole length to be the radius of my sphere. So how can I divide? I will go to math, and in math I have this division element, so I'm dragging it here. So, and you see it's A divided by B. So A will be my length of the curve. So if I can see that it's the length, right? And B will be some value. I can actually use the slider. No, I think I would rather use something. Is it okay to use the slider? Yeah, why not? Why not? Yeah. I guess I can use the slider. So, and then I will connect it. And it's much bigger than the curve because the slider is below, the value of the slider is below 1, right? So it increases. So I need to edit the slider. And if I want the radius to be always above 1, I will start with 2. And then I can set maximum to, say, to 10. Okay, okay. So, and then you see now the minimum value is 2. And I can adjust my slider. So, and it's basically now my sphere radius depends on 2 things. It depends on the length of the curve and on the divider which I use, right? So if I go to my model and I extend the curve, radius of the sphere will be also changed. So if this is an element, sometimes probably you would like it like to adjust the scale of your like the dimensions of your element dependent on the element it's connected to, right? So in a way, it even reminds, like in a way you're building something which even reminds about smart Revit elements. So what we now the only thing which I want to improve, I don't like the fact that actually I use the same curve in 2 elements as input for 2 elements, but actually I had to specify it twice. It's ridiculous. If it's one object, I want it to be specified just once. Let's see what we can do. So in params, let's see if we have curve. We should have a curve here. Geometry, curve, okay. So I find it more useful to use these drop downs. So we will drag a curve here. And now we want to set it to one curve and we will specify our curve. And now I want to feed it into 2 elements. So I will feed it here and I will feed it here. And then it's the same curve which is used twice. So and it's more natural for algorithms. If you can reuse an element, don't use it several times, not create copies, just use one source. Okay, I hope it was not too cryptic. Okay, guys, so what I suggest now, you go through, first of all, do you have questions? I hope it was quite clear. So now so just go to your elements and try to connect it to some Revit geometry and see how you can control your Grasshopper elements with your Rhino, with your Rhino geometry.
Leo,
Yes.
what does the AB stand for again?
Sorry. Oh, AB.
Yeah.
Here. So this element, if we hover over this element, it will describe itself. You see, it will say that it's division A divided by B. A divided by B, right? And what it means, the value which goes into A will be divided by the value which goes into B, and the result will be the output. Is it clear?
Kind of. So why is the B connected to, like, what does the B do, the B slider?
B slider is what we used as the dividing value. So for example, 4 divided by 2, right? It equals 2, right? So 4, so our length can be 4, our slider can be 2, right? Then the result will be 2. If we change our slider, then it will be not 2, it can be like 7, right? And it will 4 divided by 7, and it will be some result. Is it more clear now?
Yeah.
Okay, thank you. Eric, is there a way to check current output? For example, I want to see what's the value of the result. Oh, yeah. If I hover over it, then you see here, I can see it shows what's the current result. And we can, hovering over A, we can see that current input is 27, like it's measured in Rhino actually. So that's the length of our selected curve, right? So, and B is the value of the slider. So we can always check inputs and outputs.
Sometimes components will output more than one piece of information. So they'll output a list of information. So in order to see that, you can hover your cursor over the output letter, or you can type panel in the search bar, and that could also be connected with the output to show more information regarding those outputs and inputs.
Okay. Yeah, we will try to use this element in our next tutorial just to show how it works. It's all not too complicated. We are not getting even, nah, it's all pretty straightforward. Okay, and again, when you are done, just click yes. Yes?
My sphere is like really big.
Mm-hmm.
And I don't really know how to like control that, because when I slide the base, like it kind of like, I think it's something to do with the AB.
Okay, you need probably a bigger B. So what's your B now? Is it a slider?
Yeah, it's the slider.
So then right click edit and modify the range for the slider. So probably you need a bigger minimum value. So you see I took 2. So my minimum B is like my minimum radius is half of the length of my curve. But you can go even with a higher minimum value, so it will be 1/3 of the length of the curve, and probably it will help, and your element will become smaller. So use a smaller divider, or a bigger divider. Yeah.
Oh yeah. Okay. Perfect. Thank you.
You're welcome.
Where can I find the midpoint, the CM?
Midpoint, I believe it's curve tab, and you see this analysis panel. Analysis panel, it's all about how you find something within existing element, and you see curve middle. I think it is what you are looking for.
Yeah, thank you.
You're welcome. Yeah, we created a sphere, like parametrical sphere, but it's still a sphere. It's still a basic, one of the basic Rhino elements. and we would like to apply some transformation to it. So to make this form like more, say, interesting, right? So, and transformations are on the transformation tab. So, and what I would like, so, and there are some common transformations here. Just a moment. So, and what I would like to use here, I would like to use a box morph, because it's quite a complex transformation. And you see, it is quite a significantly, yeah, it's a bit more complex element than the ones which we used before. So this element takes our geometry, and it will be obviously our sphere because we want to transform it. So it takes a reference box and it takes a target box. So what this transformation is all about. So this transformation takes a box, and let's just create a box as a, how we can go about it. I would, yeah, let's do it. I will create a box. I think it should work. So, and let's, what do we have a box? We have a box. Let's create a box. No, can we go it from here? Yeah, we can use a box, say here. Yeah, I like to do this. So I will create a box in Rhino, and I want it to be a very simple box, right? Like 5, 5, 5. So I will do it by 3 points, and I will start at the beginning of the coordinate system, and I will go to 5, 0, 0. Yeah, and then I want to have press enter to use length, enter, and then choose rectangle. It is, just a moment. I want to see what it is here. Yeah, can I? Yeah, okay. And here I want height also 5. Okay, so it's just a cube, 5, 5, 5 cube, very simple. What I will do, and this cube we are referencing from our box element. So we have this box element, and we want to set it to one box, and we, oh, it can be center, just a moment, just corner the base. Oh, it doesn't allow, this element doesn't allow us to reference it. It wants us to draw it. It's okay. Okay, then I will draw it. It's just easier. Probably I can find an element which will allow me to reference this box, but I don't want to waste our time on that right now. So I will rather, when I set one box, Grasshopper doesn't allow me to choose one, so I will draw one also by 3 points. So it will be 0, 0, 0. It will be 5, 0, 0. It will be 5. It will be, yeah. It will be choose rectangle. It will be here. Yeah. So, and then 5. Yeah. So, and then, so we have this box, and we will use it as our reference box. Now we need to specify our target box. And our target box will be an unusual box. It will be what's called twisted box. Let's here. In this transform panel, we have twisted box element. And this element has 8 inputs and 1 output. So the output is a box. And the inputs are all vertices of the box. So basically, we can specify, basically, the idea is that it's a transformed box. So each vertex of, say, our box, which can be moved, it can be moved a little bit. And then it defines a transformation which basically move any point enclosed into our original box to some location into the twisted box. Okay, let's see how it works, because I'm afraid it's not very clear. So we have our 555 cube, and now we want to define a transformation of this cube, and I will define it with a polyline. My polyline, I will draw a polyline from, it will be the bottom part of my current cube. So it will start from 0, 0, 0. It will continue to 5, 0, 0. Then it will be, then it will be 5, 5, 0. Right? Then it will be, can I use, then I should be able to snip. Why it's not snipping? I do not know. Yeah, sorry. Okay, so I will use, so it was 5, 5, so it's 0, 5, 0. And then we will say that it's closed. So we specified, basically we specified a polyline which defines 4 points, and we will feed these points in our twisting box. So say point A, and we set it to 1 point, and we will change type. It's not coordinate anymore. We want it to be a curve, and the method it can be, yeah, it can be just ratio. So this is our first, it will be A, and then let's set B, it's also type curve. Unfortunately, I do not know any method how to automate it more. So it's B, it will be C, will be next one. It will be our C. Then it will be our set 1 point. And it will be our G. So our first 4 inputs, they're defined according to the vertices of this polyline. Okay, now we are about defining our top vertices. So let's create a copy of this polyline. I think I can, how can I copy it? Copy, yeah. Point to copy from, and we want to point it from here. Point to copy to, and we want to, why it doesn't allow me to choose it? I don't understand. If I choose vertex. Hi guys, do you know why it's not allowing me to snap? Oh, yeah. Why it's not allowing me to snap to it? I don't understand that. Okay. No, I cannot specify it this way. Can I do it? Just a moment. So if I create a copy, yeah, I'm not that used to Rhino modeling. So if I turn it, and then I want to copy it to, okay, and I want to copy to, it was 000, so it should be 005. Okay, this way it should work. Okay, so now we created a copy of our polygon, and let's specify the rest of our inputs. So we will start with E, set 1 point, and with this one, F, set 1 point, and will be this one. Oh, stop, did we do it? Set 1 point, so I want it to be this one. G, set 1 point, will be this one. Okay, and the last one, set 1 point, and will be this one. Okay, so now we have defined it all inputs, and this element turned light gray as I see it. So it means that now it has all parameters it needs to be functional. So, and we are feeding the result into the target. And you see it didn't affect, so now it shows several objects because by default, Grasshopper shows all elements which have been generated by the board, but we want to show only geometry of the selected object. So then, for example, if we highlight this morph element, so it is what it's produced by after the morph right now. If we highlight the sphere, we will see that it's the same. So for now, nothing is changing. Nothing has changed because our transformation, our box hasn't been transformed. Basically, our twisted box is the same as our source, like our original box. So let's try to change it. Let's go to this polyline and let's try to drag this dot. So, and let's see. No, it's not being transformed. Just, yeah, you see how it started to, being transformed? Yeah, and so when I'm adjusting basically what I'm doing, my box, which is like my original box, which is good, right? It is transforming into this weird shape box, right? So, and as it's transforming, basically, for example, somehow it stretches. If you think about the volume inside the original box, like all dots inside the original dot, there is a dot inside this original box, right? And when we are changing some corner, just dragging some corner in or out, it somehow scales down or scales up, not uniformly, scales this box, and this dot is being moved. So that's the transformation which is defined by these two boxes, like normal box and then twisted box. And that's how it affects our sphere. So, okay, I hope it is more or less you've got the idea. So ask me questions if you have questions now. Okay, no questions. Okay, as there is no questions, at this point, I don't even ask you to follow my example. Just let's stop at this point. You can, and I invite you to play with this And probably with other features. I hope you've got like some idea of what can be done in Grasshopper. So play with it, and next time we will meet and we will proceed further. Okay, so any questions before we finish? Okay, thank you everybody for participation. And I would add, if when you're exploring, if you have time and if you will explore Grasshopper on your own and you do not understand something, or you want to achieve something and you do not know how to achieve it, email me or email help.arch@ryerson.ca. We will love to hear about this. It will help us to prepare to the next tutorial. So and we will next time we will start with your questions, or we will reply right away.